Okay guys, in this next video we are going to study another type of quantitative analysis called gravimetric analysis, which is particularly useful for precipitation reactions. So the idea is that you have some sort of analyte in solution, and then you add to that a precipitating agent which causes at least a portion of that analyte to precipitate out of the solution as a solid. You can then use a device like this to filter the solution, collect the precipitate, dry it, and then measure its mass. And then based upon the mass of the precipitate, you can back calculate what the concentration of that analyte was in the original solution. Okay, so we are going to go through some example calculations of this. So in this case, here we are analyzing a 1 liter sample of polluted water for lead ions. Okay. The way that you precipitate out the lead ions is by adding a precipitating agent such as sodium sulfate. What will happen is that the lead will react with the sulfate to form an insoluble precipitate, PbSO4, which is going to fall out of solution. You can then filter the solution, collect the lead sulfate, and then use the measured mass of the lead sulfate to backtrack and calculate the concentration of the lead ions that were in the original sample of water. In this problem, they have collected 229.8 milligrams of lead sulfate, and they want us to calculate the number of milligrams of lead per liter of solution. So we are going to take the milligrams of the lead sulfate, and then we are going to convert that to grams, then to moles of lead sulfate, and then we will calculate the number of moles of lead ions in this sample of lead sulfate, and then that we can convert to the grams and then the milligrams of the lead 2+ ions. Okay, so starting with the 229.8 milligrams, I'm just going to go ahead and write that as 0.2298 grams of lead sulfate. We are going to need the molar mass of lead sulfate to complete this next conversion. And so I'm going to pull my periodic table up just to make sure that I get the right mass of lead. So 207.2 plus 32.06 for the sulfur, plus 4 times 16 for the oxygen, and I'm getting a molar mass of 303.26 grams per mole. So we're going to take the grams of lead sulfate that we have, and we're going to divide by the molar mass. Okay, so that's going to give us the moles of lead sulfate. Then there is a 1 mole of lead ions for every 1 mole of lead sulfate. That takes us to here. And then we're going to convert that to grams of lead. And so we will multiply by 207.2. That's the atomic mass of lead. And then we'll convert that to milligrams. So there are 10 to the 3 milligrams per gram. Okay, so the grams of the lead sulfate will cancel. The moles of lead sulfate will cancel. The moles of lead will cancel. The grams will cancel, and we'll be left with milligrams of lead. So running this through our calculator, I'm getting 157 milligrams out of this calculation. So in this liter of polluted water, there was 157 milligrams, and we pulled those lead ions out of solution using the sulfate ion as a precipitating agent. Okay, and so this is an example of gravimetric analysis. Let's look at another one, slightly different context. So here we are analyzing limestone, which is mostly calcium carbonate, but it's going to have some other items in the rock as well, probably. So what we'll do is we'll take the calcium carbonate and dissolve it in a strong acid, hydrochloric acid. Okay, and so the solution that's left behind is going to be essentially calcium chloride, and the carbonate will be floating. The carbonate will react with the hydrochloric acid, and so what we will then do is precipitate out the calcium ions using oxalate ions. So by adding a sodium oxalate solution, we can precipitate out the calcium oxalate. So here's the reaction that will take place. You've got in this dissolved rock solution, you're going to have calcium ions, and the calcium ions are going to react with the oxalate, and they form an insoluble precipitate, the calcium oxalate. So you will filter off the precipitate, measure its mass. It's found to be 140.2 milligrams for the precipitate. The original sample of limestone weighed 128.3 milligrams. So we're going to take this 140.2 milligrams of calcium oxalate, and we'll convert it to grams and then to moles. And then we can convert that to moles of calcium. And then we can convert that to grams and then back to milligrams of calcium ions. Once we know the milligrams of calcium ions, we can take that, divide it by the total mass of the rock, and multiply by 100 to give us the mass percentage of calcium in the limestone. So let's start with the milligrams of the calcium oxalate, and I'm just going to go ahead and convert that to grams. In order to do the grams to moles conversion, we're going to need the molar mass of the calcium oxalate. So we'll get that quickly. Pull up the periodic table. We've got 40.08 for the calcium, plus the mass for the carbon, plus the mass for the oxygen. I'm getting 128.1 grams per mole. So we will take the grams of calcium oxalate we have, and we're going to divide by the molar mass. That's going to give us the moles of calcium oxalate. There's a one-to-one relationship between the moles of calcium ion and the moles of calcium oxalate. Then, to convert from moles of calcium ions to grams of calcium ions, we need the atomic mass of calcium. So that's the 40.08 grams per mole. So we don't need the periodic table anymore. And then let's go ahead and convert that grams to milligrams. So we'll say times 10 to the 3 milligrams per gram. Okay, and so this is going to give us the milligrams of calcium ions in the solution. I am getting 43.87. No, it should be 86. 43.86 milligrams of calcium ions from that calculation. In order to get the percent of calcium ions, we're going to take the part, the 43.86, and divide it by the mass of the limestone rock, 128.3 milligrams, and we will multiply by 100, and that's going to give us the percentage of calcium. So I'm getting 34.18% from that calculation. Okay, so this is the second example of gravimetric analysis. I think there are two more examples. Here's one involving magnesium sulfate, and it's really the same strategy. There's not that much different about this problem. And then here's another one involving determining the percent of chloride in a sample by using silver ions as the precipitating agent. So this one is also similar. So I'm going to leave these two examples for you as exercises to try out on your own. And then I'm going to pick up with combustion analysis in the next video.